We just went over all the things we remember or vaguely remember about quadratic functions. I'm starting here with finite differences. First and second differences is probably how you've heard that referred to before. And this is how we can just look at a table of values to determine what type of a function is this table of values without graphing it. Does anybody remember how do we figure out the differences in this table of values to figure out what is this relationship here? Is it linear, is it quadratic, or is it neither of those things?
Don't you like count the difference between each like number? So like the difference in the like y column is 3 and then x it increases by 1.
Yeah, so we actually only have to check the x column. So this is going, it is numerical, it goes 0, 1, 2, 3, 4. So that's good, check that. But then you're looking at your y values, and difference in math means what type of order of operation? Difference means addition, subtraction, multiplication, or division. What does difference mean?
Subtraction.
Good, subtraction. So Lauren said you're looking at the y values and you're trying to see what, is there a pattern? What's happening to my y values? If I started at 3 and then went up to 6, what's the difference here? What's 6 take away 3?
3.
Thank you. You're so hesitant to answer. Okay, then it went from 6 to 9. So what's the difference? What's 9 minus 6?
3.
Fantastic. And then it went from 9 to 12. What's the difference?
3.
Thank you. And then you guys already see the pattern. All of these are the same. 3, 3, 3, 3. So is this linear, quadratic, or neither?
Linear.
Yes, thank you, Brianna. It is linear. Basically, what this is saying is every time I go up an x value, my y value is increasing by 3. It's a constant change, rate change. So 0, 3, and then it went to 6, then it went to 9, and then it went to 12, and then it went to 3. Sorry, 15. So it's going up by 3 every time, making it a straight line. I could put this on a graph and I could see it, but basically it's going up, over 1, up 3 every single time, nice straight line. If the first differences are constant, it's linear. That's in our note. So first differences will indicate if it's linear. Let's try this one. What's this changing by? 10 minus 5?
5.
Good, thank you, Makai. 20 minus 10?
10.
All right, already we can see it's not constant. 30 minus 20?
Ten.
And 40 minus 30? It's 10. So it actually almost looked like it was constant for the bottom part, but I've got this random 5 at the top. So this is not linear. So then what you do is you do the second differences. So what's the difference between these sets of numbers? What is 10 take away 5?
5.
Good. 10 take away 10?
0.
Good. And then again, 10 take away 10 is 0. Are these all the same?
No.
No. So is this is the data linear, quadratic, or neither?
Neither.
Neither. Because this would have to be the same. It'd have to be 5, 5, 5 or 0, 0, 0 if it was quadratic. So if you don't get any kind of a pattern, you just stop and you say it's neither. I'll finish the phrase linear nor quadratic. And then it could be some other kind of function. It could be exponential, or it could just be a random scatter plot. We don't know, but you only have to do up to the second differences. Let's try this table of values here. I'll do the quick math for you. So 9 minus 1 is 8. 20, oh, now I gotta do this. 25 minus 9 is 16. 49, why did I say I'd do this for you guys? 49 minus 25 is 24. And 81, oh, minus 49. Oh my goodness. I'm already struggling just to write it. Is 22. Yes? Anyone want to confirm that? That felt painful. Is that right, guys? No. Is it right? 32. Oops. I definitely want that blue. Sorry about that. Okay, now if you look at this column, these are not the same. So again, we're going to do second differences. What's 16 take away 8?
8.
Good. What's 20? These numbers got smaller. What's 24 take away 16?
8.
8. Good. 32 take away 24.
8.
Good. So what's this data?
Quadratic.
Fantastic, because the second differences are constant. Okay. So sometimes they're going to ask you guys to determine if it's a linear, quadratic, or neither of those type of relationship or function. Just based on the table of values, don't graph it, just look at the differences. Is there a pattern or not a pattern? And then make your conclusion. Any questions on first and second differences? So first differences, if they're the same, it's linear. If it's not the same, then you do the second differences. If the result of the second differences is the same, it's quadratic. If not, you're just going to write it's neither of those things.
Wait, how do you know if it's linear again?
If the first differences are the same.
Oh, okay.
We don't work with tables of values too often. We work more specifically with the actual equation for the quadratic function. So we're going to start learning how to interpret the equation. We're also going to learn eventually, like if I give you some points on the graph, how do I come up with the equation? Because it's just more useful to work with. Here, I just want to get the notes of the properties that we were talking about of a quadratic function on picture here. Let me zoom out a little bit. Okay. First of all, what did we say the shape of the graph was of a quadratic function?
A U?
Yep. And what's the name of that? Perfectly
Parabola?
good. So the parabola is the shape. It could be a smiley face like this, or it could be a frowny face. If I put a point right here, I'm going to think this is kind of the lowest point here. What's the name of that point?
Vertex.
Good. And this one is the lowest, so it could be a minimum. What if it was flipped the other way? What if it was a parabola opening like this? What would I call the vertex up here?
The maximum.
Good, the maximum. So I could have a minimum or a maximum value. Also, we're going to learn there's other points we could be looking at. What would we call these ones here right on the x-axis?
The x values?
Good, yep. So x-intercepts. I'm going to put here in the notes, sometimes in quadratic functions, they call the x-intercepts roots, solutions, or zeros. Just to make things, super confusing, you might see any of these three words. They all mean the x-intercepts. So where does the parabola cross the x-axis? Also, we talked about the fact that this is a symmetrical shape. So what would be, let me move that over. What would be the line right here that goes through the middle?
Line of symmetry.
Good, line of symmetry. Awesome.
Miss Reed?
Yeah.
This might be a dumb question, but why is there no y-intercepts? Like, why
There
didn't we have
is a y-intercept. That's not a dumb question. Hold on one second, Lauren. Axis of symmetry. or line of symmetry. Sometimes I just feel like you guys are getting good at reading kindergarten handwriting. Okay, Lauren, there is often a y-intercept. We don't focus on it as much. So actually, I'm going to introduce this to you guys, how to determine it. The y-intercept is often, if you're talking about like launching projectiles, say you're shooting a rocket or throwing a ball or shooting a basketball, bumping a volleyball, it's the height in which the object starts at is the y-intercept. So we do look at it every once in a while, but more often we're looking at the vertex or the x-intercepts. The vertex in business would be minimizing expenses or maximizing revenue. It could be if you launched a projectile, what's the highest it's going to go? I need to make sure it's going to clear the house or clear the tallest tree of the forest. So what's the maximum it will reach? And then the x-intercepts is where the projectile will land, or in business, it's what's my break-even points when my income and my expenses break even. So I at least know I'm paying my bills. So there's often more uses for the x-intercepts and the vertex, but we can also solve for the y-intercept as well. Okay? Does that make sense, Lauren? So the C value is the y-intercept, or where it crosses the y-axis. So you'll write it as a point like that, 0, and then whatever C is goes right there. So if it was +7, this would be 0, 7. If this was -11, that would be -11. There's something else, though, that this form tells us. The B doesn't mean anything to us, but does anybody remember what the A value of all 3 forms does to the quadratic function? If you don't, that's okay, but does anybody remember what the A value does?
It's probably not right, but does it determine if it's positive or negative, or?
Yeah, you're on the right track. So there's something about the fact if it's a positive, it does something. If there's a negative, it does something. Is that bringing a bell to anyone?
Isn't like if it's positive, it like faces one direction, or something? Like if it's negative, it's like no. Okay.
Yes, yes. So if it's positive in grade 10, I always say if it starts with a positive value, it's like as a positive outlook in life, it's opening up like a smiley face. So if the very first number of the quadratic is a positive, it's opening up like that, like a smile. If it's negative, it's like a frowny face, like that, it's opening down. The A value also, and this one's a little bit harder to remember, the A value also tells us whether it's been stretched or compressed. If the absolute value of A, and hold your thought, I know you have a question here. If the absolute value of A is greater than 1, then it's stretched or skinny. And if it's less than 1, then it's compressed or wide. Has anybody heard the term absolute value before? Basically, absolute value means it's distance from 0. Doesn't matter if it's positive or negative. So if I was looking at the number +7, it's 7 units away from 0. But if I was looking at -7, it's also 7 units away from 0. So you have to, with the A value, separate the sign, the positive and negative, and the number. The positive and negative makes it open up or down. The value itself makes it stretched or compressed, makes it wide or skinny. I'm going to show you guys what I mean by this. So I'm going to just go on to Desmus here so we can get a quick visual of exactly what I'm talking about. So the first equation was y equals -3x squared plus 2x minus 4. Based on this standard form, it should cross the y-axis at what value? What's my C value here? What's my C value?
-4.
-4. Does it cross at -4 on the y-axis?
Yeah.
Yes. Okay. What's my A value?
-3.
Thank you, Brianna. -3. So the negative makes it open which direction?
Down.
Down. And then the 3 means it's stretched. Now it's really hard to see that it's stretched. But if I did the same parabola, over there, the blue one and the red one, can you see? So the red one has the value, a value of 3, but the blue one has an a value of 1. Can you see that the red one is definitely skinnier than the blue one? I'm hoping you guys can see that okay. So the red one is stretched compared to the blue one, which does not have an a value of 3. So the a value makes it open down and stretched because it's a negative and it's a 3. And then the y-intercept is -4. Okay, any questions on that first graph here?
So if it's like less than 1, it'll be bigger?
Yep, so I can actually change, I'm gonna just copy this graph really quickly into my notes here for a second. If I changed that from a 3 to, let's say a 1/2, do you see how it got wider?
Yeah.
Yeah, so if it's a value less than 1, then it's gonna be wide. If it's a number greater than 1, then it's gonna be stretched. So this is how oh, sorry, factored form. So factored form, we put in our mind map, tells us what points. Does anybody remember what we said? What's the R and the S represent?
The x-intercepts?
Yes. So if I was going to write them as points, it would be R, 0 and S, 0 from here. Now this, I'm going to put this note here. It's going to look a little tricky, but hopefully you guys can see it. You do need to switch the sign of R and S. The points, the graph, and the equation are going to have opposite signs. I can explain that when we're in person. But you're going to switch the signs of R and S. The reason is in the general equation, there's these minus signs. So if I had an x value of -2, when that goes in there, it's going to be x minus -2, which is a plus. So the points and the equation will have opposite signs. We're going to look at that, so don't worry about that for now. And guys, here's the a value again. What do we know the a value does? What 2 things does it do?
It's positive, so it'll go like happy.
Good. So it does the up and down thing again. And also, what else does it do again? The stretch and the compressed. So at least you only have to remember that rule once for all 3 because the a value is the same for all of them. It will make it open up or down, and it also does stretched and compressed. So let's look at these examples. This first one, is this parabola going to open up or down?
Up.
Good. And is it stretched or compressed?
Stretched.
Good. And where are my x-intercepts?
+3 and -2.
+3 and -2. Brianna, I really appreciate you switched the signs of those. We're going to check, see if our guess is right. So let me put this in Desmus really quickly. Y equals 2x minus 3x plus 2. Okay. Is it opening up? Yes. Is it stretched? I'll tell you, yes, it's kind of hard to see right now. It is stretched. And does it have an x value at +3 and -2? Yes and yes. So if you guys want to use Desmus today, feel free to do that. I love that it's a quick visual way of just checking to make sure that what you're thinking is right without having to hand graph, because that takes a long time. Let's check the other questions. Okay, let's check the second one here then. Let me just make this way smaller if I can. The second equation, holy smokes, this is huge. Okay. All right, the second equation is -3 x minus 1 x plus 4. What do we know about this parabola?
It like opens down, like, I don't know, what's the proper word again?
Yeah, opens down is fine. It's actually, in math words, it's called reflected about the x-axis. You can just say it opens down. So it definitely opens down. What else do we know about it?
The points are +1 -4.
Good, the point, switch the signs of them though, Lauren. So it's gonna, oh, so you said that right. Never mind. +1 -4, thank you. And stretched or compressed?
Compressed.
Actually, I don't know why I haven't done one with a fraction. This one's gonna be stretched by 3. Don't let the negative sign trick you as far as thinking that the a value is less than 1 because it's -3. We have to separate the negative from the 3. The negative is going to make it open down. The 3 is going to stretch it. So it will have to be a fraction or a decimal there in order to compress it, because that's the only way for it to be less than 1 if we take off the negative sign. Does that make any sense, you guys? I hope it does. It's a little tricky. Let me put it in here. So can you guys see my graph?
Yeah.
Okay, good. So here is the parabola. You guys said it opens down, which is fantastic. It's opening down. It has been stretched, and let me just see the x-intercepts, +1 and -4. Fantastic. Okay, very good, very good. Okay. Trying to keep an eye on time. Let me put this in my notes. We have one last one to do. We're just going to quickly do vertex form. But thankfully, again, the a value does the same as the other ones.
Miss Reed,
Yeah.
can you please explain how you know if it's stretched or compressed again?
Yeah, so the easiest way to think about it is it has to be a fraction or a decimal in order for it to be compressed. So it'll be like 0.5 or it'll be like 2/3. That's when you're going to know that it has been compressed.
Okay, thank you.
You're welcome. Okay, that one is there. Okay. All right, one last one, guys. One last form, vertex form. Again, A is going to tell us whether it's opening up or down, and stretched and compressed. So actually, Lauren, we have one that's compressed here, so this should help. And then what do you guys remember about the rest of this equation? What does it tell us?
The h and the k are the values of the vertex, I think.
Exactly. The vertex is HK. Oops. I want these notes to be really complete, so I'm also going to add on here, you have to switch the sign of H because the general equation has a negative sign in it. Switch the sign of H. Because this has a negative in here, when you pull it out, you have to switch the sign of it. I'm going to hopefully show that to you guys. Okay, look at this first function. -1/2 x plus 4 minus 7. Does it open up or down?
Down.
Down, good. Stretched or compressed?
Compressed?
This one is compressed. If you made me half my height, I'm going to be smashed out to the sides. Good. So this is compressed. Where do you think the vertex is?
-4 and -7.
Good. -4, -7. So you only switch the sign of H. So -4, -7. Let's guess this one. I can graph them at the same time. Open up or down? For the second one?
Up.
Up. Stretched or compressed?
Stretched.
Stretched. And where's the vertex?
+3 and +1.
Good, awesome. Okay, I'm going to put these both in at the same time. Here's the first one. -1/2 x squared. Oh, no, I have brackets. I got it right. X plus 4 close bracket squared minus 7 was the first one. And the second one was y equals 2 x minus 3 squared plus 1. Okay, so let's look at the red one first. There it is. You guys said it was opened down, compressed, so wide, with the vertex at -4, -7. And you were correct. This is a wider parabola than we started with. So that's awesome. Open down, wide, -4, -7. Second one you guys said was opening up, stretched, and at +3, 1. So opened up, stretched, +3, 1. So you guys got both of those correct. Questions on that? Okay. So what you guys are going to do to, so we have what, 15 minutes? It should only take you 15 minutes. Let me just put this in my notes. Is please use these notes. I'm going to convert this to a PDF and I'm going to post this on Edsby for you guys. And then on Edsby, you guys do have just a quick introduction to quadratics multiple choice assessment. I want to see like where we're at with understanding these 3 forms of a vertex. So it is open now. You should be able to finish it in 15 minutes, but I did have it end at 4 today. So make sure you guys get this done. Just multiple